Can you guys all hear me? All right. I assume you can hear me. I hear something coming through the feedback. Uh, Thanks everybody who spoke today. Thank you. There was a lot of information has come across starting at 8 this morning. We've talked about a lot. Fortunately, after lunch and after cookies, we finally have a presentation with math. So this should work out well. We tried to push it as late in the day as possible to really get you guys into it. I am John Johnson. I'm from Risk Management Professionals. I have a master's from University of California, Riverside in chemical engineering. A lot of my focus at RMP actually is on HAZOP and LOPA, and I kind of run the gambit from different facilities. A lot of focus on chemical manufacturing, oil and gas, and refinery. I do ammonia and chlorine. That's typically more of a HAZOP. I have yet to find either of those facilities that really wants to dive into a LOPA. I also jump into quantitative risk analysis, QRA, as Chennai mentioned. That's just a deeper dive into these quantitative analysis, as well as development of operating procedures and control narratives. I actually like being in the field. I get a little bored in my office, so any excuse to actually get me out with real equipment kind of makes me happy, and it gets me away from everyone else in my office. All right, so the key topics. I tend to talk fast, so give me 1 second while I take a deep breath and pace myself. So this presentation is basically going to be an overview of LOPA. I'm not going to dive too deep into it, but as I'm kind of presenting these definitions for people who are a little unfamiliar with it, I'm going to introduce certain topics, and as we go, I'm going to build a very high-level LOPA scenario. So hopefully as we do this, everyone has a greater understanding of what occurs in these studies. Also, why do I care? The second part of the title here. Well, basically for a lot of facilities, there's changes to the regulatory framework. It's being implemented in places that it wasn't necessarily demanded before. Fortunately, there have been a lot of facilities, a lot of upstream oil and gas that I work with, a lot of other facilities who've already been introducing this over the years. Once again, this is going to roll out. And the other reason why I care, and I will present that as we go, it really is, for me, it is complex, but it's an easy fit into a HAZOP scenario. You can introduce this into frameworks already existing and use this to kind of override what I call dominant personalities that will often show up in a HAZOP. All right, jumping into what is the layer of protection analysis. So this has been touched on before. It's a semi-quantitative risk assessment. Basically, just like a HAZOP, we're trying to evaluate the safety integrity of our process operations. We say semi-quantitative, quantitative. It's an order of magnitude approximation. As Chennai mentioned, the math is a little bit easier. It's something you can do in a room with a team and kind of generate fairly quickly. Software does it, PHA Pro does it for you. A lot of times I'll have a spreadsheet ready, but honestly with a calculator and pen and paper, we can usually do this if necessary. Typically, I've seen these used in all sorts of places. I generally get to do these right after a qualitative study, so like a HAZOP. Generally, the corporate policy is going to dictate when you would pull off these LOPAs. So, for instance, I've been to facilities where they like to do it scenario by scenario. So you do a scenario, you develop a high severity consequence, and you can immediately do a LOPA on the HAZOP scenario developed there. Some places like to do the entire HAZOP first, then you go through, figure out what needs to go into LOPA, and then you do the LOPA. And still other facilities will say, you know, we're going to actually disband this team, generate a whole new team, and we're going to LOPA after the fact. Similar to a HAZOP, it relies on a multidisciplinary team. Chennai made a very good point. You are relying on math at this point, and if you've already done a HAZOP, you've already established your severities. So you actually could feasibly cut down your team membership slightly as long as you have that membership representation from the facility. What I like about LOPA, and I think this is the engineer in me, it's just like doing certain mathematical operations. There's a predefined set of rules. These can either come from published guidelines. I reference CCPS all throughout this presentation. A lot of times they're intra-company defined, but then again, I've seen these. I know that most of these come from CCPS, even on the corporate side. So, kind of the governing idea behind this is the risk acceptance criteria from a facility. So basically, this is what they will tolerate. Typically, it's a tableized value. For instance, here, if you look at those impact event consequences with names like catastrophic, severe, moderate, if you're in a HAZOP, maybe catastrophic is multiple fatalities. Maybe it's a single fatality. Once again, it's going to be company specific. Maybe severe is a single fatality. the important point here is what the company demands. If we cannot have a catastrophic event happen no more than once in 10,000 years. So, as I said, I'm going to generate a very high-level scenario here. So, I'm assuming we had a HAZOP. The HAZOP team ranked the consequence as severe. Since the corporate policy is to perform a LOPA on any severity consequence greater than 2, we're going to start a LOPA here with a risk acceptance criteria of 1 times 10 to the negative 3, which basically means no more than once in 1,000 years. The initiating event frequency, when Shonai kind of took some of my presentation for me, the difference between a HAZOP and LOPA, a HAZOP, we look at that ultimate potential consequence. Something, overpressure, someone gets hurt, there's personal exposure and injury. It's kind of how we always end those statements. The LOPA looks a little bit more initiating cause likelihood. The likelihood that someone misaligns a valve, the likelihood that your basic process control system fails. Whatever those events that are going to ultimately precipitate that ultimate potential consequence. Typically, the company is going to generate these based off a literature review. I stole this from the CCPS guidelines for layer protection analysis. Unloading and loading hose failure. So if you read the literature, it says 1 to 10 to the negative 2 times per year. So the company looks at that and they said, all right, we're going to look at this once per 10 years. That's the initiating cause likelihood that since we're following their rules and we're doing the LOPA, that we are going to plug in as our initiating event frequency. This is an example of a table, once again, from CCPS guidelines for initiating events. Typical ones I see all the time, human error for non-routine task. Frequency is about 1 in 10 years. Same thing as a BPCS control loop failure, expected to happen about once every 10 years. Oh, really? So I mean, it happens. And that's the whole point of... So there's 2 different ways they generate these numbers. So a bigger, let's say, refinery or a chemical plant, hopefully they'll have internal data. That's what I like the best. I like someone who goes, this is our operation, this is what we see. Typically, the literature data is going to be, hopefully they would stick to the worst case scenario that's presented in the literature data. If they said, they'd have to justify fairly robustly as to why they said, well, literature says it could happen once in 100 years, but we're going to go ahead and say 1 1,000. Mm. If they,
how willing would a company to stick their neck out for that? The literature is 1 in 100, but their data is 1 in 1,000. Have you worked with them when they say, I'll use the 1 in 1,000 because that's my data? And my data is what, 10 refineries together and
no, typically I've always seen them go the more conservative route. Right. The one time I have seen it not quite be the conservative route. So as I said earlier, that the human error is typically that once per 10 years. I've seen some event frequency tables where they'll kind of deep dive into that, and so they'll, if it's a non-routine task, they will kind of parse that out. So perhaps an operator checks it like once every hour. They'll base some reason while they say, oh, that human error actually is once per 100 years versus once per 10. I've only seen that happen once. That's rare. Almost everybody goes with that 10 to the negative 1 number. However, I have seen that somewhere. Sure.
Yeah, Tony, one of the things that we do a lot of local applications for is design. It's an environment where management wants the system design to be robust against mistakes that somebody might make in the field. They can sleep better at night if they can report to their shareholders we're protecting the equipment, we're protecting people if they use more conservative values like John is saying. Guys, higher than expected error probabilities for initiating events so that when they design the protection features, it's robust enough to protect them from people events. So from a lot of respects, a lot of initiative facility owners and operators use more conservative values.
Just feel free.
think they're doing it?
Because as a regulator, you will
Okay, I'm going to jump in, and honestly, feel free to jump in too, and we'll interact. It's late in the day. The conversation's a little easier to sit through than me talking.
I just have a assumption concerning an operation that's done so many times by one person, or how many people? Is there a population variable there?
There is not, and that kind of is the difference between this analysis and a qualitative. So we do a HAZOP, and we're going to consider those things. We're going to say, well, tell me about your field. Tell me, have you ever seen it? How many people you have touching out there? This is a little less forgiving, which is why a lot of people don't like to do the LOPA. LOPA is not hard to implement, but it's less forgiving, and we haven't even got to where I start talking about the documentation, the things you need to do to prove why you make these decisions.
Like Steve said, it's erring on the side of safety.
Right.
Well, you already told Mike. I think sometimes some companies use more conditional modifiers to give them the extra thing that they couldn't have. That's the soft side of things, right? When they say I can, no one's there, and so I'm going to give myself another factor.
All right. We'll talk about that too.
Risk assessment is like
Well, and that's the whole point. I think we're trying to move it in the LOPA is we're trying to get rid of some of the qualitative aspects of it. There's pluses and minuses both. I actually am a fan of LOPA, but it's got to be used properly. All right, as I said earlier, the math portion. So the LOPA ratio is basically you want to prove that with whatever safeguards we have in play, whatever the initiating cause likelihood, if using those all as multipliers for probability, we will defeat the risk acceptance criteria of the company. So basically, if you divide the two numbers together, you should get a 1 or greater, or number greater than 1. That just proves that your incident should happen less than what the company has stated it can feasibly happen. Just for purpose of illustration, the actual equation is going to include your probability of failure and demand, which you're going to go into much deeper in a second, as well as enabling conditions and conditional modifiers. Just for the sake of illustration, I want to point out that at this point, based on our initiating cause likelihood, we are not better than LOPA. This event will happen at much more frequent pace than the company would allow for it to happen. So probability of failure and demand. It's a value representing the probability of a system failing to work at need. I put a quote in here. What's the severity if we overpressure this vessel? We can't overpressure. It's got a PSV. This is a quote from every HAZOP I have ever been in. The reason I put that up there is because LOPA is predicated on the idea that things fail when you need it. That's the whole point, because when you do a HAZOP study, it's qualitative. And you might have a guy who's been in the field for 35 years, and he's going to go, you know what? I've never seen it. It's not possible, but industry might say different. And so what we're trying to do is come up with a concept of independent protection layers, things that we can rely on if that one piece of equipment that we need fails. Once again, I'm going to go ahead and double up on Chonai's presentation. I underlined independent because it's an independent protection layer. It needs to be independent of the initiating event. If you have a control system that failed and it closed a valve, but you have a switch that's on that same control loop, that switch isn't going to help you because the control system thinks everything's great. That's why it opened the valve. So the first thing you're going to ask, and you're going to look in that PNID, you're going to go, hey, and they're going to say that we've got a pressure switch high on it. It's going to shut everything down. Well, it's on that same control loop. It's happy. It's not going to do anything. So it should also be independent of other IPLs. These are other safeguards. Once again, it's that layer of independency. So your first level could be that basic process control system. If it fails, you have an alarm. Can the operator react? Maybe they can do that. Maybe the operator fails to do that. Well, then you got a pressure relief or some other system in play. Each one is that independent protection layer that's going to stop this ultimate consequence, this overpressure event, from actually happening. What I like about LOPA, there's rules. This is a very simple overview. Generally, if I'm doing a LOPA, I'll actually have access to the books, and we can just pop out an entire sheet. And if they go, okay, well, we've got an alarm, I have certain questions I'm going to ask. Can an operator be expected to respond in time? Are switches maintained, calibrated, and inspected at regular levels? A pressure relief, is it sized for the appropriate case? Like I said, these are baseline questions. There's more that actually get involved in an actual study. These independent protection layers, they can be passive, active. Once again, there's rules governing what we can use. As a sidebar, kind of, it's not going to enter in the equation I'm doing now, but enabling conditions. These LOPA event frequencies are on a per year basis. So everything's based on, once per 1 year, once per 10 years. However, if you have some sort of seasonal risk, so if you're an ammonia facility, you're an ag plant, and you only worry about ammonia refrigeration during the summer, you kind of want to take that into consideration because we're going, well, it's once per year, and you're like, well, I use it, 25% of the year. That simply factors into the equation, and it gives a more honest picture, and that's what LOPA is supposed to do, provide a more honest picture of what's happening in the field. The important point between enabling condition and a conditional modifier, the enabling condition modifies against that initiating event ever occurring. Once again, seasonal risks, process state risks. If the process is not always using that hazardous chemical, well, you're not really going to calculate what's going on in those off times. Conditional modifiers, as we have brought up, the favorite one to ever bring up in conditional modifiers is personal presence some percentage of the time. This is, to my mind, an overutilized modifier. It's a true modifier. You just have to calculate it honestly. So if I'm in a PHA and they go, oh, well, we have one operator who goes out there once a day and he checks for 5 minutes. I'm like, cool, that's less than, some percentage of the time. But of course, they also have maintenance personnel. They've got housekeeping personnel. And oh, the unit's on the way to the lunch area. So they've got traffic all day. So those are the questions you ask during a LOPA. It's all about proving and making sure that you can support those numbers if anyone ever asks you, why did you develop this particular percentage? Typically no, because the level gauge goes into operator surveillance. So unless that operator is stationed out there 24/7 looking at that gauge, typically they're not going to catch it. And basically the rules of LOPA would pretty much prohibit it. Whereas in a HAZOP, maybe you could demonstrate, oh, well, the operator checks that gauge once an hour. It's an increased level in a 40,000 barrel tank. It's going to take 3 days. You might be able to use that. It wouldn't fit in the LOPA. Okay, so once again, here's where I go back to what I was hitting before. Layer of protection analysis, the values are documented and defensible. So these are just examples that I've seen and that I ask for if someone tells me, we're going to use this sort of probability, we're going to use this event condition. For dispersion modeling, that usually goes to probability of developing hazardous atmosphere. I've had those come up. Typically, if you're doing a design stage HAZOP, maybe during the feed stage, the question was raised, so someone did the dispersion modeling, they bring it in, you go, oh, okay, we're not actually going to develop that hazardous atmosphere, but we've got a paper trail that says it. Someone did the work to study it. Maintenance records, that goes to demonstrating the reliability of your IPLs. It shows that they're being maintained, it shows that they're being inspected, and they're being calibrated. Once again, all those rules that LOPA requires you to do. Policies and procedures, once again, this goes back to the personnel presence. If you've got signs up and you've got a policy and procedure that says, they've got a lunch area on this other side of this, but they're required by our policies and procedures to walk all the way around the plant. They've got something that says this is only authorized personnel. They just have to demonstrate this is why we're saying that no one's going to be out there except for some percentage of the day. Electrical classification, I threw this in as an example. Once again, it goes to probability of ignition. Probability of ignition is a little harder to calculate. Typically, it takes time, so you really won't see it pop up in the study unless someone's done the work and can prove it in the study. Back to our example. I brought up the probability of failure demand. These, once again, representative table, a very easy one. This is a probability of failure and demand based on industry best practices. Basic process control system will generally fail about once every 10 years. A human being will fail to respond about once every 10 years. Spring-operated valves are considered a little more robust because they're mechanical.
Probability of ignition. Are you assuming that there's an electrical source?
It's simply, it's one factor. So, once again, and that's why it has to be developed, because different chemicals are going to have different reactions to hitting oxygen. And we also, right. trucks, cell phones, all that stuff comes into play. Okay, so probability for demand. We factor this into our, I'm building my little LOPA scenario here. I had my conversation with my team. I looked at it. It was as a pressure. We don't believe the operators can respond to the alarm quick enough. The shutdowns are on the same control loop. So basically I asked them, well, what do we have? We talked about the pressure relief device. It's got that 10 to the -2. I asked the questions, is it sized for this event? Is it calibrated and tested on the appropriate frequencies? And once again, typically what I'd ask for, and they don't necessarily have to show me the document, but what I'm going to say is, do you have a reference number for the work orders that says this is being done? And I'll just pop it in as part of my safeguard. It's just a parenthesis at the end. Now, this little note here, I see this a lot in design, so typically I'll always add a recommendation. So if we are going to credit this, I'm just going to say, make a recommendation to ensure this device is added to a critical instrument list, and then I'll define the critical instrument list as requiring those certain maintenance activities, which means we can rely on this piece of equipment. Okay, that was the very quick introduction to how I would apply LOPA. All I was trying to say or point out, it is fairly easy to implement, but as we saw from the questions that came up, it's unforgiving. There's rules. You can go, what about this? Well, LOPA says no. Or what about this? LOPA says yes. We can move forward with it. So why do I care? As we said earlier, I stole this from Steve's presentation. There are changes coming. This is associated with the SPA as part of the new Program 4. If you look at the definitions here, assess the effectiveness of existing and combined safeguards for each failure scenario identified in the PHA. Evaluate passive or active or procedural safeguards. LOPA pretty much meets these criteria, which is why it's been explicitly called out in many of the places you see in these regulations changing. So, my summary of this, why I particularly like LOPA. Once again, it helps override certain strong-willed people you can get in a team. Sometimes it's hard to reach team consensus, and people tend to go with those who might have experience or those who are stronger personalities in a study. And for something that's not a hazard, so maybe a first aid injury or something like that, that's why most companies give that criteria where you don't have to LOPA those. But if it's an explosion, people are going to die, then typically you want that added level of protection that LOPA offers. Our recommendation, of course, as these things are approaching, is just tag it on the back of an HAZOP. The team's already there. Once again, this will be up to each facility to decide how they want to implement. But it's really not hard to do in session. The hard part's going to be the documentation and making sure you're keeping up with the recommendations that are made. Now, is it LOPA in 20 minutes? All right. Is there any other questions?